Okay, I want to do a video on part of our 3-3 guided notes. All right, near the end, there were some questions related to writing the equation of the tangent line. And then there were some talking about second derivatives. And I thought I would just do a video on those two pieces. Okay, I'm going to go ahead and get a little more paper. I know I'm going to need it. Let's look at this one, number 70. This is from the 3-3, which means you may need to use the product rule and or the quotient rule. All right, so on this one, we're being asked to get the equation of the tangent line to the graph. All right, so the second I see that, I know I'm going to need to take the derivative of the function. So I'm going to go ahead and do that. My plan is going to be to get the derivative of the function in general. Then I'm going to come back and I'm going to use this 0.47 to figure out what the slope would be. The slope for the tangent line would be at that point. And then I'm going to write the equation of the tangent line. Okay, so first we're going to do the derivative of this function. So this function has a function of x on both top and bottom, and there's more than one term in the denominator. So you would want to go ahead and just use the product rule. Now you could bring the denominator up to the top and rewrite the function this way. Oops, that's a minus. Rewrite it as x plus 3 and then have the x minus 3 to the -1. You could do that and just use the product rule, but most people find it easier to go ahead and just use the quotient rule. Okay, so I'm not going to do that. All right, so that means I need the derivative of the top function, which is 1, times the bottom function as is, minus the derivative of the bottom function, which happens to also be 1, times the top function as is, and then all of that's over the bottom function squared. Okay. Now, I'm not going to really ever multiply out that denominator, but I am going to try to simplify this numerator. So that would be x minus 3. Then I'm going to distribute the -1 and get negative x minus 3. Okay. All right, so the x's cancel out, but then I wind up with a -6 over x minus 3 quantity squared. Okay. All right, so now what I'm wanting to do is get what is the slope of the tangent line to the curve at the 0.47. So I know that, so at 47, at that ordered pair, x equals 4. So f prime of 4 would wind up equaling -6 over 4 minus 3 squared. So I'm really thinking about that now, getting the actual value, and that's a little prime symbol right there. Let me make that clear. Let me get that to erase. All right, so right here, that's really the prime symbol on that. So it's still a derivative. So f, I'm plugging 4 into f prime, and I'm getting -6 over 1 squared, and that would just be -6. Okay. All right, but that's not all. I'm supposed to get the actual equation for the tangent line. So now I'm going to plug in, I'm going to think about, I know m equals -6, and I have this ordered pair 4, 7. So I'm going to plug into this formula, the point slope formula. So y minus y1 equals m times x minus x1. All right, so then I'm going to distribute the -6. So that would become plus 24 there. And then I'm going to add 7 to both sides. And I'm going to wind up with -6x. When I add the 7, I'll get plus 31. So this would be the final answer on that one. So the idea is really 3 steps. Get the general formula for the derivative, okay? Then come in and find what the value of the slope is at the particular point. Then go in and work on getting the equation of the tangent line, okay? So we're going to do that same process again, but we're going to do it with a trig function. Get my cursor in here, give myself a little more paper. Okay, let me move that back up here. And let me get that off of there. Okay, so now we're going to do this again, but we have a secant function. But same plan. So I'm going to do f prime of x first. And this isn't really a product or a quotient rule, but we just talked about secant in this section because secant is really 1 over cosine. So it's actually they used basically the quotient rule to come up with the formula for the derivative of secant. You just need to know it. You need to memorize these. So the derivative of secant is secant x tangent x. Okay, that product. It's an understood times right there. Right, so we need the value of the derivative at the point pi over 3, 2. So this is your input value. This is your x, so that's why I plugged that in. So that's secant pi over 3 tangent pi over 3. Okay, so you may be able to go and think about that directly, but if you're going to try to use your calculator or when you're trying to use the unit circle, sometimes it helps just to remember that tangent is sine over cosine and that secant is 1 over cosine. So actually, I'm going to think about that. Go to my unit circle. Pi over 3 would be right there. It's really the same as 60 degrees. Okay, and then I'm looking at this triangle right here, and I remember the coordinates of that would be 1/2 square root of 3 over 2. Notice that the short piece is in the x direction, so that would be the 1/2. All right, so now I'm going to plug in the values that I get for cosine and sine. So cosine was 1/2. Sine is square root of 3 over 2. Okay. And all right, so I wind up with this expression right here, and it looks a little weird. Let me clean it up a little bit. So fractions, the way they work, you multiply straight across. So it's really 1 times the square root of 3 over 2 over 1/2 times 1/2, which would be 1/4. All right, so really what I have is square root of 3 over 2 over 1/4. So I'd like to clean that up a little bit. So I'm going to multiply by the least common denominator because that'll knock out that denominator, and 2 goes into 4 twice, and I wind up with 2 square root of 3. Okay, now you really should focus on things being done exactly, not doing decimal approximations for stuff. Okay, all right, let me get some more paper. All right, so now I know that right at this point I've got the value of the derivative of the function at pi over 3. So that's the slope of the tangent line to the curve at that point, pi over 3, 2. So there's m, and here's the point. So I'm using that y minus y1 equals m, and then x minus x1. Okay, so I'm going to put in the 2 for the y1, the 2 square root of 3 for the m. I'm going to put in x minus pi over 3. Okay. Now, sometimes, let me move that down a little more. Sometimes with trig functions, your result can look really bizarre. So normally I like my resulting equations to be in slope-intercept form because it gives me the most information. Okay, so here I'm multiplying 2 square root of 3 times both pieces to distribute. So that would be 2 times pi times square root of 3 all over 3 there at the end. All right, but on this one, when I do that, I wind up with kind of a bizarre result because I would also wind up adding 2 to both sides to get the y by itself if I did that. Okay, now let me just back up a minute. Getting things in slope-intercept form in a non-trig function, is great. was 31. It changed. All right, so we got y equals negative 6x plus 31. So, that works out great. But you might have noticed that a lot of times in the back of the book, they're putting things in, I think the term is general form, where everything's on one side equal to 0. All right, I personally don't like that because I can't at a glance, that right there, for instance. So a lot of times they'll put things in this form. It's not even standard form. So this, the way I like it is where you can see the slope and you can see the y-intercept at a glance. And then standard form is when you bring the x and the y over to the same side and your constant is on the other side. But a lot of times they do this form. That's called the general form. Okay. So that's, I would guess, what they would leave the answer in here. Because if I add 2 to both sides, okay, let me put the x. I'm going to put the x there so it doesn't look like it's under the radical. So I have a 2 times the square root of 3 times an x. So that's 2x square root of 3. And then when I add 2 to this, when I'm trying to add 2 here to this side, okay, think of that 2 right there as being 6 over 3. So it's really like I'm adding 6 over 3 right here. All right, so that looks funny. You can't, they're not like terms. It kind of looks messy. And you wind up getting this. So if it's in slope-intercept form, it's not a very pretty looking form. So on this one, what they're probably going to do is this. They're going to take that step right there. And instead of adding 2 to both sides like I did, what they're going to wind up doing, I'm going to write that step again. They're going to go from here and they're going to put it in general form. So let me show you that. Okay, so that's where we were. Okay, getting it in a slope-intercept was a little bit awkward. Okay. What I could do is clear out the denominator, okay, right there by multiplying through by 3. So that would give me 3y minus 6 equals 6 square root of 3 times the x minus 2 pi square root of 3. So that gets rid of the little fractions. Okay. Then what I could do is I could bring everything over to the left-hand side. Okay. So I'm going to bring the x over, keep the y where it is, keep the minus 6 where it is, and bring the 2 pi square root of 3 over and get all of that equal to 0. All right, and then I like my x term to be positive, so I'll go through. Okay. Oops, that should be minus right there. Okay. So that's probably how you'll see it in the back of the book. All right, so this would be the slope-intercept form, not particularly pretty. This would be another okay way to leave it, which is called the general form.